Okay, we're on problem B7, once again a no calculator problem. And it looks similar to an earlier problem, but this I think is so much more difficult. And I'd really like for you to go over my solution if you didn't get this one right. All right, so here we have a piecewise linear function, and that's a function of f, and then they give you that we have another function, and that's an area function. Okay, g is the area from 2 to whatever x value of this function up here. Okay, so before we move on, and we have to be really careful. Okay, if I gave you an easy x value like 6, okay, g of 6 is just the area from 2 to 6, and that's just a triangle right there. But if I had given you x is negative 4, so g of negative 4, okay, realize that this would become the integral from 2 to negative 4 of f of t dt. And I would want you to flip these. And I want you to remember that, maybe I should be writing a little darker here, that if you flip the limits, okay, you'll have to change the sign of the integral. And so this is ever less than 2. Don't forget, you're going to have to change the sign of the integral. All right, so problem A. Does g have a relative min, max, or neither at x equals 10? Okay, so x equals 10, I'm right there. Like I said, this is a more challenging problem than we've done. Okay, so if you think about it, if we're looking for a min or max, we're being asked a question about the derivative of g. Okay, and the derivative of g, here's g, right here. The derivative of both sides would give me the derivative of g, and this, I hope, strikes you as a fundamental theorem of calculus problem. And the derivative of this antiderivative, note that we just get the original function. In other words, the derivative of g at x is the y value of f for that given x. Okay, and so they're asking about x equals 10. Okay, they're asking, is there a min or a max there? Okay, and so the derivative of g at 10 is equal to the y value of f at 10, and we look back at the picture, the y value is 0. So the slope of g at x equals 10 is 0, and so it's possible. Maybe there is a min or a max. But then since the derivative of g, which is the y value of f, on either side of x equals 10, here the y values are negative, so g's slope will be negative here. Here the y values are negative, so g's slope will be negative here. And if we were making a sign chart for this part of the problem, where I'm looking for the derivative of g, I have a negative sign and a negative sign and a 0 derivative here. I should say negative derivative, and a 0 derivative there. So the function would be going down, and then slope of 0, and then going down again. It's neither a max nor a min at that x value. So that was a tricky problem. Okay, part B. Does the graph of g have an inflection point at x equals 4? So now we're being asked for the second derivative. Okay, remember, to have an inflection point, we have to have the second derivative being either undefined or 0, and we need a concavity change. So on part A, we talked about how the derivative of g was the y value of f. Well, that means the second derivative of g is the first derivative of f, and that's really easy. The first derivative of f is just the slope at any given value. And we're being asked about x equals 4. So that's our point right here. Okay, so once again, the second derivative of g at x equals 4 is the slope of f at x equals 4, and the slope of f at x equals 4 is undefined. So possibly we may have an inflection point there. note that the slope here is positive. The slope on this side of that x value is negative, and so we get a concavity change. Okay, here we would be concave up, here concave down, and there we have an undefined concavity, and that is an inflection point at x equals 4. Okay, part C. Find the absolute minimum value and the absolute maximum value on this closed interval. Okay, so this is the value of g, actually g. Okay, so note, one of the first things I did is I found the area under each part, and I just broke it down into little triangles, and they nicely happen to have areas of 4 or negative 4. Okay, once again, it's just 1/2 base times height. And we're going to use that on this part. Okay, so what we're looking for is where we have a min or a max. Okay, and so that's going to be where our slope is either undefined or 0 for g, or an endpoint. So we're going to look for critical points and endpoints. Remember, the slope of g is the y value of f. So I'm asking, when is f equal to 0? Let me just look at the graph. Okay, here I have an endpoint, 0, 0, 0, 0, and an endpoint. And so those are the places, those are my critical points and my endpoints. And those are the values of x for which I want to evaluate g. I'm looking for the max or min. Okay, and so when x equals 4, this is what we were talking about earlier. Okay, here, because g of x equals the integral from 2 to x, okay, g of negative 4 is the integral from 2 to negative 4, and I'm going to flip these limits so that I can just say, okay, I'm going to find this area from negative 4 to 2, and I'm going to make it the opposite of whatever I find. And so the area, where did I do that? The area from negative 4 to 2, I just add up all those. Remember, anything below will be negative, and so I get a negative 4, 4, and 4. So the y value of g is negative 4. If that's the lowest or the highest of all the y values, that would be one of my absolute mins or maxes. I do the same thing for all of these different values here. Okay, if this is lower, okay, I'll flip it, make it negative, and these are just the areas of the included triangles. This one's the easiest one. The area from 2 to 2 is just 0, and these were pretty straightforward. I found all of my y values. Okay, here I had the maximum, here I had the minimum, and so you would say there's an absolute max of 8 at x equals 6, and an absolute min of negative 8 at x equals negative 2. Okay, so then this one isn't too bad. On this closed interval again, find all intervals for which g is 0, negative or 0. And so here, okay, we have from negative 4 all the way to 2. These are my values. Okay, I found them once again by finding these areas. Okay, and my area gets so low here that it doesn't return to 0 until we get to x equals 2. And so g is negative from x equals negative 4 to x equals 2. Okay, and then it's positive for a while. Remember, g is just the area under here, so positive for a while, but then we start taking some away. It finally reaches 0 again at x equals 10, and then it's decreasing all the way to x equals 12. And so we go from 0 to a negative 4, so the area would be negative on 10 to 12 also. Your next problem is a no calculator problem, and there it is. Good luck.